Question 35, it's 2020 June, Mathematical Science. So let gamma be the positively oriented circle in the complex plane given by z. So gamma is z minus 1 mod of z minus 1 equal to half. So it is a circle centered at 1, 0 with radius half, right? And we have to find the value of the line integral. Integral gamma z e to the power 1 by z z square minus 1 dz. So z has two roots, z equal to 1 and z equal to minus 1. So z equal to 1, it is inside gamma and it is outside gamma, right? Centered at 1, 0 with the radius half. So let fz be a function. This is the z equal to e to the power 1 by z into z divided by z square minus 1. By Cauchy integral we can write Cauchy integral. So Cauchy integral formula, we can write is integral fz dz is equal to 2 pi I into multiplied by the sum of residues of fz. So it can be written as 2 pi I sum of residue of fz. So z is z equal to 1, so limit z tends to 1, z minus 1 multiplied by fz. You put the value of fz over here, z into to the power 1 by z, z square minus 1. So after simplifying, this z minus 1 and z minus 1 will cancel out. So it will be 2 pi I limit multiplication limit z tends to 1, z into e to the power 1 by z divided by z plus 1. So if we put the value of z 2 pi I into, so z1 e to the power 1, it just will be e, and 1 plus 1 is 2, so 2 to cancel out. The final value of the line integral will be pi I. Let's check with the option. So option is 1. Option 1 is the correct answer. I pi e. Question 36 is p be a positive integer and the closed curve is given rt e to the power it, where t varies from 0 to 2 pi. Let f be a function holomorphic in z, where z mod z is less than r and where r is greater than 1. So mod z is less than 1, it should be greater than 1. Yeah, so f has a 0 only at z0, and z0 mod z0 lies within this value 0 and r. Multiplicity, it is a multiplicity q. We have to find the residual value of this integral. Okay, 1 by 2 pi I integral f prime z by fz. So let write this fz is equal to z minus 1 whole cube, and f prime z will be 3z minus 1 whole square. So here q is equal to 3, the multiplicity, and f has a 0 only at z0, z0 equal to 1, and if we took that p equal to 2, then we can write this 1 by 2 pi I integral of r. F prime z is nothing but 3z minus 1 whole square by z minus 1 cube, and z to the power p is z square dz. It can be written as 1 by 2 pi r 3 of z square by z minus 1 dz. So this is the sum of residues of this integral 3z square by z minus 1 dz. So you can write it in this residue at z equal to 1, 3z square by z minus 1. So here the limit z tends to 1, 3z square by z minus 1 into z minus 1, right? So it will be the value of the residue will be 3. So here we have 1 by 2 pi I integral r f prime z by fz dz. It's not dz, it will be z to the power p dz is equal to 3. Now we have to check with the options. So option 1, q z0 to the power p, which is 3I square is equal to 3. Option 2 is z0 q to the power p, 1 3 square, it is 9, p of z0 to the power q, z0 to the power q, it is 2 1 cube is 2. Option 4 is z0 p to the power q, so it is 1 to the power 1 into 2 to the power 3, that is 8. So here I can see the option 2, 3, 4, these are all incorrect. Only option 1 is correct. So here it is the option q into z0 to the power p. Option 1 is the correct.